Alright folks, welcome back to Moonshine Radio here again. Today we're going to cover single sideband reception using GNURadio, and that's what we'll cover today. A link below this video has all the GNU flow graphs as well as a IQ file that you can use to follow along with this video. Okay, slide 2. Once you download that file, the IQ file, it will contain in the spectrum 3 single sideband signals. One upper sideband signal at a 32 kilohertz offset, and then another upper sideband signal at a negative 12 kilohertz offset, and a lower sideband signal also with a negative 12 kilohertz offset. And the IQ sample rate of this file is 96 kilohertz. And you can download it. It's in a link below this video. Alright, let's get into the meat. So, how we're going to be demodulating these single sideband signals, we will not be using the Weaver method. That's a stupid method, particularly for DSP. We're going to read in the file here. We're going to focus on the single sideband signal that's at a 32 kilohertz offset. We're going to use the frequency X lighting filter. Wow, okay. And then we're going to decimate the signal by 6. So that's our final sample rate will be 16 kilohertz. Now, in reality, single sideband signals are never going to be exact. So that's why we include this little tune factor here to get our signal truly at DC. And that's what that e to the j 2 pi f tune is. After that, we're going to run it through a complex bandpass filter. Oh boy. And it's only going to allow positive 100 hertz to 5 kilohertz. And you can change that if you like, but that's what I've done. Once we've run our signal through that to guarantee that only one single sideband has been filtered, to get the audio, all we need to do is just take the real part of the IQ stream, and that will be the audio. It really is that simple. Once the signal is in IQ, that's all we have to do. I've seen people converting it back to float and back to complex and all this madness. You don't need to do that. All you need to do is just get your single sideband signal to DC, run it through a complex filter to guarantee that only that one either upper sideband or lower sideband signal is present, and then just take the real part and you will have the audio. Okay, slide 4 here. Now, how did we make this complex filter? Again, it's in GNURadio. You can just download the flow graph, but for those of you that want to know the math, basically it's just we make a low-pass filter, and then we simply multiply it by this complex phasor here, and now this filter has imaginary parts and real parts, so it's complex, which allows us to make this single-sided filter that you see here. And we're only allowing 100 hertz to 5 kilohertz to go through. And that's how we're going to filter out the upper sideband signal that we want. All right. Hopefully that was real clear. All right, slide 5. Again, this is our final spectrum of what's in the IQ file. And for those of you that would like to decode that lower sideband signal that at a negative 12 kilohertz offset, the audio will contain an Amazon claim code, so you can get some money there. Now, I'll give you one hint to get the lower sideband signal to work. After that multiply in the flow graph with the frequency tune, simply just need to insert a complex conjugate block, and that will flip that lower sideband signal to an upper sideband signal, and like magic you'll be able to decode what's in that Amazon claim code, so you can go buy some goodies on Amazon. Again, a flow graph, flow graphs, and the IQ file are all in a link below this video, so just download them, open them up in your GNURadio, and you too can demodulate single sideband signals by Dr. Moonshine's method, which I hopefully you will agree is rather simple and easy. Alright, that's it. Live from Moonshine Radio University, this is Moonshine Radio.
Introducing the Red Kataya STEMLab 12514 4-input. We took our best performing board with 2 inputs and 2 outputs, which is widely used by engineers around the globe, and redesigned it to offer 4 input channels and improved technical specifications. The STEMLab 12514